since I want to show you things on here, and I know that, you know, you can't see them from back there, I thought I'd try putting them on the screen. We have a document camera, but it's not hooked up. And I've asked for it to be hooked up, but it just never does. I thought it was like a siren at first, you know, like it was going to be an alert. Okay, so one of the measurements that we're going to need for the lab is the radius of this this thing that's going to be the axle, and your lab refers to it as a shaft, and this thing is the threaded rod. So we want to get this radius to as accurate a number as we can measure, so that's why we're going to use this vernier caliper. So let me see if you can see this up on the screen, okay? Oh, well, maybe not. Is there too much glare on that? You can sort of see what's going on, right? Yeah. Now, when this is completely closed, it's so weird because it's backwards. When you look at your image on the screen, it's not like looking at it in a mirror. And my impulse is to move it the way I would move it in a mirror. So, where's it? Okay, now here's the deal. I guess you're not really going to be able to see that very well. But you use this little, there's a little thumb screw here, and you just use that as like a wheel to open and close these jaws. And you put whatever you're going to measure the diameter of, or the thickness of, inside the, or in the jaws, but not in the indented place. Okay, so you see what's going on there. And then you can actually lock it in place. There's a screw right there. So I just locked the jaws in place. Now, let me help you get oriented to this. I wish you could see the numbers here, but I can't see them. Can you see them? Okay, so I'm guessing I want the numbers on this part right here. I'm thinking it's a little over what, 1.2. Okay, so those two numbers, one's a 0 and one's a 1. And could you see those? I can't see them on this screen. Could you see them on that one?
No.
Is there a way for me to make it bigger? Who knows? Seems like there ought to be, but I don't see any obvious ones. Settings. No. All right. Well. So what this reading is 1.2, and then if you look at the dial here, it's between 7 and 8. Would you say, is that at like, how many notches past the 7 is that? Can you see it?
No.
You can't see it up there?
At least half.
Yeah.
Okay, so I'll look. You see what I'm looking at, though?
Yeah.
Okay. So I'm going to call this measurement 1.275. Not only is it at least half, I would ballpark it at half. So I'm saying the diameter of the shaft is 1.275. .75 centimeters. But we're going to want everything in meters. So how many meters is that? Move the decimal how many places?
2.
2. Which direction?
Left.
Right. I mean, correct. Okay, so that's the diameter of the shaft. Now, really, you should check this out and see if you can measure something, because it's a handy little instrument, and it would be nice if you knew how to read it. But I always have to think about it when I use this. I always have to look at what's going on here. You get the first 2 digits from the reading on this scale, then you get the next 2 from the dial. It's called a dial caliper. Okay, so let me show you what's going to go on in this lab, and then we'll talk about the measurements that you're going to make and all that stuff. Wasting time. All right. So we talked about rotational inertia in class on Tuesday, and I gave you formulas for rotational inertia of a solid disc, a hoop, a solid sphere, and for a rod pivoted at the middle, at its center. And so we're going to use those formulas today to calculate the rotational inertia of, actually we're going to have the shaft, the threaded rod, and then on each end of the threaded rod, as far out on the rod as you can get it. So maybe a little farther than that. We're going to wedge a 100-gram mass, but that one won't fit. Will this fit? So we've got these, you're going to have 4 wing nuts. So that's how it will look on one side. And then on the other side, that's weird. That same 100-gram mass fits on the other end. It must be bent on that end or something. Okay, so you want to be sure you get that clamped on tightly. It will start to move pretty rapidly when you get the heavier masses on the end. That's going to spin around a lot. So what you're going to do is exert a torque on this shaft via the tension in the string, and you want to have that string be as close to horizontal as possible. So just pay attention to that. And what you're going to do is, starting from the same height every time, you're going to let the falling mass accelerate the system. And you'll see it'll start rotating faster and faster. My distance here is about 0.89 meters. Your distance, I think, is going to be around 0.75 meters, around 75 centimeters. You will want to measure that and maybe make a mark on the table that marks the height you're going to drop the masses from, because you want to keep that constant. All right? So you're going to make the main measurement you're going to make after you get all the diameters and the masses and such is you're going to time the descent of the mass. Then you're going to use that time along with some other things to calculate angular acceleration of this thing and the torque that's being exerted on it. So that's what's going on just in general. Now, we may want to stop the video after I apportion out all these jobs and then just have them, and then we'll have them come back for when we have all the numbers. What I'm gonna do is we're gonna make some of the first measurements all by ourselves. I mean, as a group. I'm not gonna send you off to do it all by yourselves. So I'm gonna have somebody measure the mass of the 4 wing nuts, and then we're all gonna use that same value. And I'm gonna have somebody measure the length of this threaded rod, and then we need the mass of the threaded rod. There's a table in your lab book, maybe on the second page, that we're gonna fill out. Yeah, go ahead and shut it off.